Good morning and welcome to this month's edition of the economics webinars. My name is Dr. Cristie Preston and I'm a senior agronomist with Nutrien. I mainly cover the Midwest region. So if you're joining us from other areas today, I'm sorry, I did focus the presentation more on the Midwest just because that's where my specialty is. Welcome. Here in my hometown, we have actually, or where I currently live, we've actually gotten rain within the past 36 hours, and it's a blessing because we haven't seen very much precipitation this year. And I feel like after I looked at Twitter this morning, that's what a lot of you all are getting as well. So let's keep doing those rain dances. Today, we'll be discussing some science-based nutrient management in times of high fertilizer prices. And by science-based, I mean agronomically and economically feasible practices for this year. There is a Q&A down at the bottom, so please utilize it for all questions, and hopefully we'll have time for those at the end. This webinar is being recorded and will be posted to the eKonomics website at nutrien-economics.com, and that's economics with a K. We did apply for CEU credits. However, we haven't heard back from those, but I do have a slide at the end that has an email address that we would love for you to send your name and your CEU or your CCA number to get those credits at a later time. And with that, we'll jump in and get started. Again, today we're discussing science-based nutrient management practices in times of high fertilizer prices. Earlier this year, we did have several Nutrien employees give a presentation on kind of the outlook that they saw for fertilizer in 2022. I'm not really going to discuss fertilizer prices per se, but mainly talk about kind of like what the abstract said, talk about what I could have done as a farmer before 2022 that may have made this year a little bit easier. And then we'll talk about maybe some decisions that need to be made for this planting season, or what I can be aware of for this crop season that will hopefully keep my ROI high and make me a little bit of money in these uncertain times. I always like to start off the presentation with basic nutrition, basic nutrient management, and then we'll go into really the fundamentals behind taking a good soil sample, understanding the soil tests, and the different management strategies that are based on these soil test methods. Plans for 22, we'll talk about crop rotations, nutrient management plans, and how our economics tools can be utilized during these times. Y'all are probably tired of seeing this slide, but number one, law of the minimum. Your yield will be limited by your most limiting factor. So in times of fertilizer decisions, guess what? Your most limiting factor is probably going to be your first question that you need. Well, actually, your first question is, what's my soil pH? The second question is, what's my most limiting factor, so that I can get that adjusted so I can increase my yield. And what does that mean? At economics, we have the dam, which the dam holds back the water or the yield potential. And as I have these holes in my dam, I'm potentially losing yield, whether I don't have enough sulfur, whether I don't have enough potassium, phosphorus, or water, which, I mean, if you look at the drought monitor map, the majority of the Midwest and Western Plains and over into the Pacific Northwest, we haven't seen the rainfall or precipitation that is going to be needed even last fall and into the spring. So we need to make sure that we do plug these other holes that of the factors that we can control, the nutrients. And this also can include herbicide use and managing pests. But if my yield is going to be limited by my most limiting factor, I need to make sure that that's applied. And we'll discuss more about maybe we need to be reprioritizing these nutrients. We'll talk about that here in a little bit. IP&I did a great job of surveying soil test levels within the states and many of the provinces in Canada. On average, soil test levels for phosphorus are declining, and that's due to high removal rates, not applying enough fertilizer, it can even be due to more pure fertilizer sources. We're removing a lot of impurities and making them more just nutrients and pK. For various reasons, soil test levels are decreasing across the US and Canada. So check out the IP&I database, see, kind of where your state's lying. I currently reside in Kansas, and so 47% of the soil samples that were analyzed by the labs that they had access to were testing below critical levels for phosphorus. And we'll talk more about critical levels here in a little bit. Same story for K, not as significant or not as bad in many states, but still considerable areas where soil test levels have decreased over time. And if you want state-specific information, you can actually check out the Geographic Tool on the Economics website, where you can select your individual state and get the trends of consumption of fertilizer versus removal rates, and kind of look at the overall balance. You can also use other economics tools to monitor kind of a mass balance of your farm in general, where you know what you're applying. You can use a removal calculator to calculate what you're removing and making sure you're at least supplying that amount. And then, of course, what could I have done before 2022 to kind of set myself up for times of high fertilizer prices? I could have taken a good soil sample. Okay, basic agronomy, how to take a soil sample. Make sure you use clean tools. Sample at consistent depths. Here I have a graph from Kansas State where you can see the dark blue areas are areas of higher, I believe this was phosphorus sampling. The dark blue areas have that stratification on the soil surface. Okay, so if I'm taking it only 4 inches deep, maybe my soil test level is coming back at 22 as opposed to 15 if I am sampling 6 inches deep. Now, how does that affect how I apply my nutrients? Well, if you're assuming you've got a 22 part per million, that's above the critical level in Kansas. And so, all right, maybe my recommendations aren't to apply any fertilizer this year because it is above the critical level, where the probability of seeing a response to fertilizer is lower. And we'll talk more in a minute about how these soil test levels are correlated and calibrated to what the crop sees and can give you the best estimate on whether or not you'll see a crop response. Collect enough cores. The main goal of soil sampling is to try to measure the variability within the field. And if I don't take enough soil samples or enough soil cores, say on a 2.5 acre grid, I need to take 15 to 20 cores so that I get down here in the bottom of this graph whenever it's starting to level off. And that's going to give me my most accurate soil test level. And again, the soil test or the soil laboratory is only analyzing maybe 3 grams of soil at most. And so thoroughly mixing those cores together to form one sample is key. That way you're getting the 0 to 2 area mixed with the 4 to 6. That's just an example of how I mix it together to get that parts per million. Now, I said the number one question of what I could have done in previous years to work my way up to this year. Walk onto a field, the first question I ask a farmer is, what is your soil pH? Because that is key. There can be enough nutrients in the soil, but they may not be chemically available to the plant because of the pH. And say phosphorus is the most notable for when you're adjusting your pH to increase availability, because at too low a pH, free iron and aluminum are in the soil and can potentially bind the phosphorus. At too high a pH, free calcium or calcium carbonate is in the soil and can bind phosphorus. So really trying to keep it in this sweet spot of just below 6.5 to just above 7, you have the maximum amount of nutrients available. So number one question, what's your soil pH? If I can start here, then I correct my pH. I can make sure that when I do go back to soil samples, say for phosphorus and potassium, the levels that the plant's going to see are available, and that translates into my soil test. Okay, so now that we've taken the best soil sample we can, how does the university actually determine how much fertilizer to apply, or do I need to apply fertilizer, and how much fertilizer to apply? So universities have spent a lot of time working on the correlation between soil test levels and crop response. So if I build my soil up to a certain soil test level, at what point do I no longer expect to see a crop response? And that varies based on crop. As you can see here in this graph, I've included one, again, sorry, from Kansas State University, looking at corn, grain sorghum, and wheat plotted on the same map. But they all follow a general trend where if you increase soil test levels, eventually you will get up to that percent relative yield or maximum agronomic yield and economic yield. So really the correlation question is answering the question, do I need to apply fertilizer? Because the universities have set critical levels based on economically optimum rates to apply fertilizer to get to those, or agronomically optimum levels to build those soil test levels up to maximize yield. Now, on the other hand, the calibration is pretty much the relationship between the fertilizer rate that you're going to apply based on your soil test levels. So if I have low soil test levels, I will need to apply more fertilizer to get to that agronomically optimum yield. If I have high soil test levels, I'm not going to need as much fertilizer to maximize my yield. So again, calibration curves are answering how much fertilizer to apply based on the soil test levels. So the critical levels are the points at which no fertilizer, the crops are not supposed to respond to additional fertilizer. Now that can vary based on, take phosphorus or take potassium, for example. I granted the graphs here are phosphorus, but take potassium, for example. If I have wet soils like we do outside today, the potassium is more than likely going to come back higher because the soil is wet, the clay mineralogy is expanded, and more potassium is available. In drier conditions, those soil colloids can collapse within their layers and potentially trap potassium, and your soil test levels may not come back as high. So knowing what time of year to soil sample and not sample too dry or too wet can really aid in determining your soil test levels and your critical. So the critical levels are really set for the point at which I expect to not see any fertilizer response. And at the end of the day, that's what you want. You want your soil test levels to be above these critical levels, because you don't necessarily want to have areas within your field where your soil test levels aren't high enough and you're also not applying enough fertilizer. So is there some benefit to maintaining your soil test levels um, above critical level? And I'll explain why I do agree and kind of always promote a build to maintain approach. So if you think about, you've got your field and you've separated it out on, or you've laid it out on a 2.5 acre grid. Within that 2.5 acres, you can have what you call spatial variability. Again, the main goal of taking a good soil sample is to measure this field variability. And so if I take one sample in 2.5 acres there, and it comes back at say 100, and it comes back at 106. But for this given example, over here in the second picture, the critical level is 160. Well, even though it came back 165, it's above the critical level, but you may still have areas within that 2.5 acre grid that fall below at 142, 152. But you're treating that 2.5 acre grid as one sample, and you're going to apply fertilizer based on that one sample. So a build to maintain approach would build the levels in the soil above the critical level and keep them high enough that you wouldn't necessarily have these areas. They would all turn green and all be above that 160 range. Now, again, at the end of the day, we need to make sure that we're doing this as environmentally sound as possible as well, but also try to maximize yields. So I've got my soil test information. I understand the different, how universities calculate critical levels with correlation, and then calibration, how much fertilizer to apply. In my mind, there are two main systems or two main management practices for nutrient management. There's the sufficiency approach, which is where you're feeding the crop. And at economically optimum levels, there may not be a recommendation for any fertilizer to be applied if my levels are built up high enough. Usually this type of system can be used in a year like 2022 when fertilizer prices are really high. But again, caveat statement, this is assuming your soil test levels are above critical levels, so that you're not leaving any areas within your field subject to yield losses. In this type of approach, if you are going to do this every year, you're going to fertilize every crop every year. And mainly you're looking at removal rates. And as I said earlier, the eKonomics website, nutrien-economics.com, economics with a K, you can use the nutrient removal calculator to get some idea of site-specific what your crop is removing that year. The limitations with the sufficiency approach are you could limit your yield because you're only always going for 95% of the max yield, because that is the economic optimum rate. And you're really not planning for the future. And so last month, I actually gave a presentation on the benefits of using a starter. And for a year like 2022, a starter application is a great management practice that you should probably take advantage of. because if you've built up your soil test levels, you need to ensure that you have enough fertilizer out there early enough that the crop's not going to be limiting. But again, sufficiency approach, there's no future consideration. This is also maybe the type of approach that a renter or someone who doesn't own land may take to manage their nutrients. On the other hand, the build to maintain, you're really feeding the soil. You're always shooting for 100% maximum yields. You're building up above critical levels, slightly above. I'm not talking about as much as maybe 10 part per million, 20 part per million for some nutrients above critical levels. But if you're thinking about spatial variability, you could do a better job of taking soil samples to further manage that variability if you feel like you have it in your field. But you're really trying to keep those levels above where you're not going to see a fertilizer response. The sufficiency approach, you could potentially see a response to fertilizer application that year. High early inputs, so maybe next year, whenever, or say 2 years ago when fertilizer prices weren't as high, I could have invested in inputs early on, and then after that I maintain a sufficiency approach. So you can utilize both types of systems, but know the limitations of both. A general rule of thumb is for every 20 pounds of phosphorus that's added above crop removal, the soil test will increase 1 part per million, and vice versa. And so earlier we talked about how soil test levels are decreasing in many of our agriculture soils. If I'm continuously removing phosphorus or potassium and I'm not applying enough back, I will see a decrease in soil test levels over time. Now, there is some buffer capacity here because the soil likes to stay in some type of equilibrium, but these are two general rules. For potassium, for every 6 pounds of K added above crop removal, you can increase your soil test levels by 1 part per million. And this definitely varies by soil type. All right, so let's move into considerations for this year. And I like to throw in for our nutrient stewardship, because we're looking at fertilizer prices per source, or we need to look at our rates that are being applied. Timing of application can be key this year to make sure that we're really increasing our nutrient use efficiency by matching up timing, and of course the right placement. All of this while also maintaining some economic balance and also protecting the environment from additional losses. That overall, fertilizer applications, if I can check off all 4 of these boxes, then more than likely I'm not going to have large amounts lost to the environment, and that can help save on my ROI. So we talked about timing, really understanding when nutrients are taken up the most and matching those uptake levels with fertilizer applications can maximize your ROI. Now, specifically with phosphorus here in figure number 2, there is some lag time. And again, my presentation last month that talked about starter application, specifically with phosphorus in year 2022, a starter application may decrease, or maybe decrease this lag time of uptake, make sure that there's enough phosphorus out there, especially as we see a horrible roller coaster of soil temperatures. It was 80 degrees here, not one day last week, and there was a 40-degree temperature and it snowed. since we don't know what really the temperature is going to do, and if corn's already in the ground, starter is a great option for making sure that the plant's not going, make sure the plant's not going to develop any type of deficiency symptoms. Okay, so I've decided that I have built up my soil test levels above critical. I've did a great job of building those up. Now I put the crop in the ground. The next thing that I would suggest farmers be aware of is being able to determine nutrient deficiency symptoms. And my first example, of course, is phosphorus, because it can occur in cooler soil conditions, maybe drier conditions as well. This is not Kansas State corn. It is purple from the sugar accumulation in the leaves. You're more than welcome to read on about the phosphorus functions in the plant, but if phosphorus is limited early on, that can decrease your yield potential later on. But again, if I've applied starter fertilizer, more than likely I'm not going to see these phosphorus deficiency symptoms, and more than likely the crop will grow out of it. I included this slide just because I feel like it's lesser known that if we can apply fertilizer early on, make sure that the crop is not struggling or stressed, then you can potentially increase its time to maturity, and that can lead to cost savings with grain dry down. And in this example, I mean, as much as $7,000. But again, making sure that the crop is not stressed early on, specifically with phosphorus in a starter fertilizer, that would be key for maybe quicker grain dry down whenever it comes to harvest time. So the things that we do today, the moral of the story is the things that we do today can potentially affect how much additional cost savings I can have at the end of harvest. Just to include potassium deficiency. Potassium is actually a nutrient where, I talked about it earlier, where the wetting and drying of soils can make potassium more available or less available. So in-season applications is a possibility with a nutrient like potassium. So potassium deficiency occurs on the lower leaves because it is a mobile nutrient within the plant. It's most noted for this yellowing of the outside edges. Potassium functions in plants, water use efficiency. I live in Kansas. Western Kansas does not get a lot of precipitation during the growing season. And so potassium fertilization is key to help out with water use efficiency, disease and pest resistance. And potassium is also a nutrient that can be taken up in luxury consumption. Some benefits of potassium applications in soybeans. Research has shown potassium applications leads to more pods per plant, more beans per pod, and fuller beans. That increases yield. Potassium can help again against pest stress, and it also can help against drought conditions that can be caused by compaction or just the lack of precipitation in general. Potassium has also been found to respond to in-season applications. So if I see those deficiency symptoms, know what tissue samples that I can take. Since different varieties and different hybrids vary so much, we're trying to pinpoint the values that nutrients like potassium need to be at to show that they are sufficient, but it's more of a diagnostic tool, this tissue sampling is. Maybe if I have an area in the field where I believe there may be deficiency symptoms, then I'll take a sample from that and directly compare it to maybe a darker area within the field. But consider that a crop like corn can take up between 8 and 10 pounds of potassium per day. And especially in a time of drought or low precipitation and no irrigation, then maybe a potassium application is warranted because maybe I know my historical data on my field, and I know that from year to year, if it's dry, I see potassium deficiency. So consider a side dress application for potassium if I've seen historical deficiency symptoms, and if it's a dry year, that's something I can do to maximize my ROI. Now, over the past couple of weeks, we've been having several conversations about, is it practical, or are there reasons why I may not switch up my crop rotation? And so agronomically, should I switch from corn to soybeans this year because maybe the fertilizer inputs aren't as high? We'll look at some Illinois crop budgets here in a minute, but here are my top 4 considerations for whether or not I need to, or agronomically, if I should switch from corn to soybean. Or actually, we can flip these around and say, hey, should I consider switching from soybean to corn this year? Because that's definitely a topic of conversation. But understand, if you're going either way, realize that there may be some loss of rotational effect. And as little as a couple of percent yield loss, but you generally, on average, a crop grown behind another crop, whether it's corn behind corn or soybean behind soybean, there's an average of 10% yield loss just because of all of the stresses that the next crop will undergo. Herbicide rotation. If I applied corn herbicides last fall, I'm probably going to have to stick with corn this year. Or maybe I need to consider alternating chemistry if I do grow the same crop behind the same crop, to reduce the instances of herbicide tolerant weeds, resistance within the field, make sure that I have all my broadleaves and my grasses covered. Pest pressure probably should be number 1, because if I am switching from corn to soybeans, then I'm worried about soybean cyst nematodes, sudden death syndrome, and white mold, just to name a few. Those are the top 3. If I have instances in the field where they've occurred the year before, even though I've chosen the right genetics, and I have, I've done everything that I can to keep from having soybean cyst nematode pressure be high, I'm probably going to see it the next year, and it's probably going to be higher than the previous year. But again, that's based on, that could be based on environmental issues. Fertilizer management. If I've applied a lot, or if I've applied high amounts of nitrogen in the fall, I'm Midwest based, so if I applied anhydrous this past fall, probably should be sticking with corn, since soybeans is a leguminous plant. Those high amounts of nitrogen in the soil are going to kind of render the process of the nodules being formed by hindering the process of the rhizobia infecting the root hairs. And so if there are high amounts of nitrogen, that soybean plant is not going to biologically fix as high amounts of nitrogen. I need to make sure that soybean plant can take off. And if there's high amounts of nitrogen, it's not going to. Other fertilizer management, soil test levels and removal rates for phosphorus and potassium. So I'm throwing in a scenario here. So assuming a field that is capable of producing 230 bushel corn would also produce 60 bushel soybeans. So again, not really looking at the previous year's crops, just looking at starting new for this year. The corn crop will remove 0.38 pounds of phosphorus and 0.2 pounds of potassium per bushel harvested in the grain. Soybeans will remove 0.8 pounds of phosphorus and 1.3 pounds of potassium. So I've actually graphed it out to see what that looks like. Now, assuming this field is capable of producing both of these levels of corn and soybean in a given year, keeping all management, not really considering other economics of production, but how much P and K would be removed if these crops were grown this year. As you can see, corn will actually remove higher amounts of phosphorus compared to the soybean, but the soybean plant will remove 1.3 pounds of potassium per bushel removed. And so if I'm looking at this, I'm thinking I need to make sure that if I'm switching over and I'm growing soybeans this year, I need to make sure that I have enough potassium out there, because the crop's taken up more than this, and this is just what's being removed. Okay, second scenario with the same data. Now I've grown soybeans last year, and if I want to switch over and grow soybeans again this year, I better be looking at my potassium levels in the field, because I know that 1.3 pounds of potassium have been removed per grain bushel that I produced last year. Make sure that I have high enough levels. If I'm switching over to corn, phosphorus may be the bigger question with making sure that I have high enough levels. But if you've, kind of stuck to a build to maintain approach, you may not have to consider applying as much to make sure that you maximize yield. So Illinois actually does a great job of putting out their crop budgets, and specifically for 2022, I checked this out this morning, and depending on where you are in Illinois, actually in most areas, they're pretty close. Corn and soybeans are both about the same for profitability. There are other tools that you can use as a farmer to determine, maybe in your specific area based on prices, what crop may be economical for you. But, going back to 2 slides ago, make sure it's going to work out agronomically based on herbicides and fertilizer decisions. And so I'm not going to go into detail of what these budgets take into consideration, but it can be found at Farm Doc Daily, and they talk about general trends for maybe the entire Midwest as well as the different regions within Illinois. But as of right now, if prices stay similar to what they have been, corn and soybeans are both about the same whenever it comes down to the farmer's return on investment, which is this bottom, which is this second to last line down at the bottom. All right, so let's shake things up whenever it comes to NPK. There has been quite a bit of research and quite a bit of data that is suggesting that if both soil test phosphorus and soil test potassium levels are low, maybe we need to be reprioritizing to NKP with our supplemental fertilizer applications. And this is actually probably due to various reasons, but the topic that I tend to think of first when I look at NKP is there are other forms of phosphorus in the soil as organic matter. And so if I do have some level of organic matter breakdown during the growing season, that can supply phosphorus to the plant. And there are various other reasons. As we stated earlier with soil tie-up of potassium, But just be aware that some research, and this is from Nathan Slayton out of the University of Arkansas, he found that soybeans tend to respond better to potassium than phosphorus. And I'm not specific. I don't know the specifics on the soil conditions at this general location, but just note that we probably need to pay a little bit more attention to phosphorus, because historically we haven't, or sorry, to potassium, because historically we haven't. The same story in Wisconsin. Dr. Carrie Lebowski has the study which looks at the combination of potassium and phosphorus applications. And I took 2 screenshots here of the video that we have on the eKonomics website where, okay, we're not really seeing a grain yield increase with increasing phosphorus applications here in this first graph. I've highlighted the phosphorus, but, and granted, this is when both soil tests, phosphorus and potassium levels are both below critical. I may need to consider potassium applications, because year after year, from 2012 to 2016, I do see that increase. And this is irregardless of what phosphorus was applied. So it could have been 90 pounds of phosphorus applied, but I'm still seeing this yield increase with potassium application. All right, now the big question is, what rates of fertilizer do I apply this year? And I draw your attention to the ROI calculator on the eKonomics website. Here you can enter in site-specific information where you can choose your crop, and there are some limitations with the current model because we are subject to what is available from universities and published data. But you can play around with various scenarios. You can go with what nutrient or what levels are recommended from the university based on the area that you chose. Nutrients, enter in your number of acres so that you can get your farm specific information. You can even go in and choose which fertilizer sources you would like to have. So one scenario you could work up is how my ROI might change if I change phosphorus source or if I change nitrogen source. Really, we tried to make a tool that you could use on your farm that would help you out at the end of the day. And if you have any questions on this, there is a tutorial that walks you through several scenarios of comparing, hey, I've been applying this same amount of this fertilizer for the past 10 years. What happens if I increase it just a little bit? And it takes into account that spatial variability that we discussed earlier, where maybe my soil test levels aren't exactly high enough, and I can kind of mask that spatial variability with additional fertilizer applications, but also increase my yield at the same time. All right. Oh, the other comment on rate is also the eKonomics tool, which is the nutrient removal calculator. Entering in site-specific information, what my yields were last year, making sure that I'm at least applying what was removed last year if my soil test levels were built up high enough. All right. So in conclusion, I talked about basic nutrient management, understanding Liebig's law of the minimum. That's going to be key this year because my yield is going to be limited by my most limiting factor. Proper soil sampling is something that I consistently see producers not taking full advantage of, and maybe not sampling at a low enough resolution. The good thing about sampling at a low enough resolution is I can always go up. I can't go more specific. And so understanding those soil tests and how they're how the soil tests have been correlated to crop yield, and understanding how the calibrations have how they help determine how much fertilizer I need to apply is going to be key to fertilizer applications this year. The different management strategies. Again, if I've done a great job of building up my soil test levels, maybe I can get by with just a starter application, or making sure that I've at least applied removal rates. Or actually, the economics removal calculator does give you uptake levels as well. And so you can take a look at those uptake levels and see where to make sure that the soil has enough nutrients in it, because at the end of the day, that's what is going to be needed to maximize yield. Removal rates are just easier to calculate because, hey, I made 230 bushel corn last year. How much phosphorus and potassium do I need to make sure? Plans for 2022. Again, there are several agronomic reasons for maybe not switching over to a different crop this year, because there are benefits of the corn soybean rotation and or corn soybean wheat, double cropping wheat behind soybeans. There are various options that you can employ. And take advantage of our economics tools. They're out there for producers like you to utilize and use your site-specific information. Again, there is a question section down at the bottom, so please feel free to submit your questions there or on the economics website. We did apply for CEU credits, so at this time, we're still pending, but if you could send your CEU number or your CCA number, your name and your CCA number to Suzanne Fletcher at Nutrien.com. We will get you on a list, and if you have any issues getting those credits, she'll also be the one for you to reach out to. Again, I point out the Q&A question box down at the bottom. Science-based nutrient management in a year when fertilizer prices are high. It's going to be difficult to invest highly in any type of fertilizer this year, but we can do it more efficiently, especially using a tool like the 4R program, where we're constantly questioning, it's not a set of guidelines. It's just, in my mind, it's a set of questions. What can I be doing? What is the next question I need to answer? Okay, I went from applying all of my nitrogen in the fall, so maybe this year I'll start split applying. I'll apply some type of fertilizer or starter application. Maybe I'll do an in-season application. Anytime I can better match fertilizer applications with nutrient uptake, that's going to potentially increase my ROI. I didn't really discuss it a lot here, but using any type of enhanced efficiency fertilizer will probably pay off this year if the particular environments do offer a high probability of fertilizer or nutrient losses. I draw your attention back to the economics website, where we do actually have an app now. It can be downloaded on Apple or Google or Android-based phones. Again, it's in your hand. Yeah, I can be standing out in my field. Okay, let me pop out the rainfall tracker and just see. I didn't even talk about the growing degree day calculator, where, maybe I need to check where my plants or where my crops could be, because I've had this many growing degree days or this many heat units up until this point. The other cool new thing in the economics world is shout out to my coworker Mike for being the host of our new podcast called The Dirt, an economics podcast. Again, that's economics with a K and podcast with a K. If you have suggestions on future webinars, I mean, we always have things that we can talk about, but if you have suggestions or questions, please feel free to reach out. Okay, so for CEU credits, please reach out to Suzanne. If you're going to be watching the recording, we will have a short quiz for you to answer some questions to get those points. And we will let you know whenever this webinar is available online. And I believe we do have time for some questions. This webinar was sponsored by eKonomics. That's eKonomics with a K at nutrien-economics.com. And do I? Sorry, I don't have, I can't see the Q&A.
Hey, Cristie, I'm looking at the
questions. Oh.
Yeah, I'm just looking at the Q&A here. Nothing's popped in yet. We did have that one that was submitted prior, and I can pass that one to you, or if you know, we did, if there's anything that you have.
Oh, you did. We did discuss that.
Yeah.
Yes. So we had a question in regards to kind of several scenarios that I already discussed. Soil test levels were above critical. Can I just get by with starter application this year? And the short answer is yes, you should be able to. But I also suggest that you pay attention to your crop, make sure that you're able to identify nutrient deficiency symptoms if they persist. But in theory, yes, if your soil test levels are built up above critical, whatever the crop you may be growing, then a starter application may be enough. I don't feel like I have anything else to say. Oh, there, I do.
One question just popped in here, Cristie. I can read that to you. In a starter, is there benefit of both P and K for corn and beans where levels are above critical?
Yes, and thank you, Brian, for that question. Starter consisting of nitrogen, phosphorus, and potassium would be beneficial for both crops, especially for various reasons. Specifically phosphorus, if it's a cooler growing season, if we were planting earlier. Well, actually, no, you said what you said for corn and soybeans. So a crop like corn, being able to get the phosphorus out there earlier, and you're more than welcome to go back to last month's presentation that talked about starter applications and the benefits there. Specifically for soybeans, I've seen some research that shows that soybean plants do also like being fertilized, as opposed to just instead of just relying on building up soil test levels. So starter, P and K, both for corn and soybeans, should be enough this year. All right, if you have any additional questions, please feel free to reach out on eKonomics and follow us on Twitter. And I hope you all have a great day. It's raining here, so we're all doing a fun dance. Thank you all.